Everyone thinks spaceflight began with German V-2 rockets. They're profoundly wrong. The true genesis of humanity's reach for the stars wasn't a wartime weapon, but the quiet, relentless work of an American physicist ridiculed as Moon Man and Crazy Goddard. His name was Robert Hutchings Goddard, and his story is a testament to vision in the face of widespread scorn. Born in 1882, Goddard was a sickly child, often confined indoors. It was during these solitary hours, devouring H.G. Wells' War of the Worlds and First Men in the Moon, that a singular obsession began to take root: how to actually get there. His eureka moment arrived at age 16 on October 19, 1899. Climbing a cherry tree in his backyard, he envisioned a device that could travel beyond Earth. It was a clear, vivid image that would define his life's work: a rocket propelled by pure reaction. This wasn't just a daydream. Goddard was a meticulous scientist. He pursued physics at Worcester Polytechnic Institute and later Clark University, dedicating himself to the theoretical underpinnings of rocketry. This was decades before anyone seriously considered space travel feasible. By 1914, he'd secured two groundbreaking patents, one for a multi-stage rocket and another for a rocket fueled by liquid propellants. These concepts, now fundamental to spaceflight, were revolutionary. No one else was even close. His early work was largely theoretical, but the First World War pushed him into practical application. The U.S. Army approached him to develop a small, man-portable rocket weapon. His answer, the precursor to the bazooka, demonstrated in 1918. But Goddard's true passion remained space. In 1919, he published a method of reaching extreme altitudes, a paper that meticulously detailed the physics of rocket propulsion and even discussed sending a flash powder charge to the moon for visibility. The public reaction was brutal. The New York Times, in particular, famously ridiculed him, publishing an editorial that scoffed at the idea of rockets working in a vacuum, claiming he seemed to lack the knowledge ladled out daily in high schools. This public humiliation, though deeply painful, didn't deter him. Instead, it pushed him further into his solitary work. He understood something his critics didn't. Space wasn't an empty void. It was the ultimate vacuum, perfect for rocket propulsion. His focus shifted to liquid-fueled rockets. Solid rockets were simpler, but liquid fuels offered far greater control and efficiency, essential for reaching orbital velocities. This was another radical departure from conventional thinking. On March 16, 1926, on his Aunt Effie's farm in Auburn, Massachusetts, Goddard achieved something truly monumental. He launched the world's first liquid-fueled rocket. It flew for a mere 2.5 seconds, reached an altitude of 41 feet, and landed 184 feet away. To the casual observer, it was a tiny, unimpressive leap. But to Goddard and to history, it was humanity's first true step towards the stars. This wasn't a firework. It was a controlled, sustained reaction in a never-before-seen engine. Word of his work eventually reached influential figures. Charles Lindbergh, the legendary aviator, became a staunch supporter, securing critical funding for Goddard from the Guggenheim family. This allowed him to move his operations to the wide-open spaces of Roswell, New Mexico. In Roswell, from 1930 to 1941, Goddard and his small team built increasingly sophisticated rockets. They pioneered gyroscopic stabilization, thrust vectoring, and even developed the first turbopump innovations essential for modern rocketry. He meticulously documented every experiment, every failure, and every success. His journals are filled with detailed sketches, calculations, and observations. He was not just building rockets, he was building the foundational science of spaceflight. By the late 1930s, his rockets were reaching altitudes of over 9,000 feet, demonstrating controlled flight and stability. While still far from space, these were leaps and bounds beyond anything else being developed globally. Ironically, as Goddard toiled in relative obscurity across the Atlantic, German scientists were studying his published works. Wernher von Braun and his team at Peenemünde openly acknowledged their debt to Goddard's pioneering research. The V-2 rocket, which reigned terror during World War II, incorporated many of Goddard's fundamental innovations. It was a weapon, yes, but its underlying technology, liquid fuel, gyroscopic guidance, stemmed directly from Goddard's crazy ideas. Goddard himself was aware of the German progress, offering his expertise to the U.S. military during WW2. However, his ideas were largely dismissed or misunderstood by an establishment focused on immediate, conventional weaponry. He died in 1945, just months before the end of WW2 and years before the space race truly began. He never saw Sputnik, never saw a man walk on the moon, never witnessed the vindication of his lifelong pursuit. It took decades for his contributions to be fully recognized. In 1960, 15 years after his death, NASA posthumously awarded Goddard's estate a staggering $1 million for patent infringements, acknowledging his foundational role. The New York Times even published a retraction in 1969, on the eve of the Apollo 11 moon landing, admitting its earlier error. It is now definite, they wrote, that a rocket can function in a vacuum, a quiet, profound apology. Today, every rocket that launches into orbit, every satellite, every mission to Mars, owes a profound debt to Robert Goddard. The Moon Man wasn't crazy, he was simply decades ahead of his time, a forgotten pioneer who laid the very first stones on the path to the stars. To uncover more forgotten pioneers who shaped our exploration of the cosmos, make sure you're subscribed.